Maupay nga adlaw sa iyong tanan. Welcome to my channel. Our topic for today, division of line segment. So line segment may be divided internally when the point of division is on the line itself, or externally when the point of division is on the extension. To illustrate, let's consider 2 points. So we have, for our first point, x sub 1 and y sub 1. Second point, p sub 2, x sub 2, and y sub 2. And for our third point, which divides the line segment joining the given points into two parts in a certain ratio. So we have the third point which divide the line segment. We have x and y. To illustrate this figure, so for example, we have a Cartesian plane, and we have a point 1, x sub 1 and y sub 1 connected to our point 2, x sub 2 and y sub 2. Then connecting these 2 points, and we have the third point which divide the line segment into two parts. So we have the point P which divide our line segment into two parts. Okay, so this figure is an example of a line segment with internal division. Why? Because the third point is found at the middle or within the line segment P1, point 1 and point 2. Okay, let's have another example for a line segment with external division. Okay, our second figure, so this is our figure A, and this is our figure B. So our figure A, we have a certain line, point 1 and a point 2. So let's connect these 2 points. Okay, the external division of the line segment is extended or extended to a certain terminal point, which in this case we still don't know. So we call it our point P with x and y. So our point 2, x sub 2 and y sub 2. Our point 1, x sub 1 and y sub 1. Okay, so see the difference. So for internal division line segment, the point is located in the middle or within the line of directed line, whereas in the external division of line segment, your point is located beyond or extended to a certain terminal point. To a certain terminal point. So this is your certain terminal point. Okay. So if we have this figure, okay, so let's evaluate the figure and derive the formulas. So if we're going to draw this figure applying similar triangle method, therefore this portion, based on our previous lesson, and this portion is equal to your x sub 2 minus x sub 1. Whereas here is equal to your x minus x sub 1. So we can call this R S. Or for our external division, so okay, so this is a similar triangle, so we can call this vertex S and R. So I hope it's clear that the figure A is our external division, and for figure B, these are external division of the line. So let's draw the auxiliary of this given two figure. So for our auxiliary line, P sub 1 R R1 and P sub 1 R1 and P sub 1 S. So for our external division in a figure B, we can draw our point R, P sub 2 S, and P on R through S. Okay, this is through S, while the other is through R. Okay, consider the line segment of point 1 and P as directed starting point sub 1 and terminating at point A, and the line segment point sub 1 and point 2 which start at point 1 and terminates at point 2. So let's let the ratio P sub 1 R bar over P sub 1 and P sub 2 equal to RK. What is RK? So for both figures, for both figure A and B, your K is always positive for both external and internal division. So both positive in external and internal division of the line segment P sub 1 P and P sub 1 P sub 2 line segment. So now the coordinate of the P can be found by similar triangle. it's obvious that it's right triangle, and we have a smaller triangle and a bigger triangle. So we can apply similarity of triangle with the consideration of figure A and B, especially in finding the coordinate P. So in finding the x coordinate P, so is equal to your x sub 1 minus x sub 2 minus x sub 1, or recalling our ratio k, but our p over p sub 1 is equal to k. So therefore, rk is equal to x sub 1 minus x sub 2 minus x sub 1. So solving for x, we can have x is equal to x sub 1 plus your k quantity x sub 2 minus x sub 1. So this is your formula in finding the x coordinate. Okay, let's solve for y. Solving for y, our k is equal to y minus y sub 1 over y sub 2 minus y sub 1. So therefore your y is equal to y sub 1 plus k y sub 2 minus y sub 1 dt. So this is your formula in finding your y coordinate of P. Okay, so I hope it's clear the formula for our division of line segment. So let's proceed to our next slide. So our next slide is midpoint of the line segment. As we recall, we previously derived our formula in finding x. So as we recall, in finding x, in finding the x coordinate of P, we have x is equal to x sub 1 plus k quantity x sub 2 minus x sub 1. And for y, in finding the y coordinate of P, so y sub 1 plus k y sub 2 minus y sub 1. So this is our two formula. So midpoint of the line. So when the point of division lies exactly at the middle of the line segment. So if it is in the middle, if it is in the middle, based on our previous figure of a line segment, our P sub 1 bar over our P sub 1 and P sub 2 is equal to K, which is 1/2. Our K for our midpoint of a line segment is 1/2. So to determine the formula for a midpoint in a line segment, so if we have, so let's assume that our point of division is P and X sub Y, and your PM is your middle point. Okay, so substituting the formula with our K, solving for XM, X, the middle, so X sub M is equal to X sub 1 plus your K and X sub 2 minus X sub 1. So we all know that our X at the middle of a line segment is 1/2. So substituting the value, so X sub 1 plus 1/2 quantity X sub 2 minus X sub 1. So substitute the value, X sub 1 plus 1/2 X sub 2 minus 1/2 of X sub 1. So combining like terms, giving 1/2 X sub 1 plus 1/2 X sub 2, or simply X at the middle is equal to 1/2 X sub 1 plus X sub 2. So this is our formula for finding our middle distance XM in the middle of the line segment. So similarly for your Y, solving for YM, so Y middle is Y sub 1 plus K, Y sub 2 minus Y sub 1. Again, our K is equal to 1/2. So substituting the value, Y sub 1 plus 1/2, Y sub 2 minus Y sub 1, Y sub 1 plus 1/2 Y sub 2 minus 1/2 Y sub 1. Combining like terms, magiging 1/2 Y sub 1 plus 1/2 Y sub 2. So finally, our YM is 1/2 plus 1/2 quantity Y sub 1 plus Y sub 2. So these are formula for our YM. Okay, to illustrate our given formulas, let's have an example. So our next slide is an example for determining the line segment. Okay, example number 1. So the line segment joining A and B is divided into 3 equal parts. So the problem requires to find the division nearest to P. Okay, so our first procedure in solving this kind of problem is, first we need to illustrate or plot the given points. So for example, we have certain point. So point A, 2, 2, and for your Y, this is -6. So at this point, we have our point A, 2 and negative 6. So our second point is 8 and 3. So 8. And for your y is 3. 3. So we can plot the location of our point B. So our point B is 8 and 3. So what are the other details in the problem? So the line segment joining A and B is divided into three equal parts. So if we connect this point A and B, according to the problem, it is divided into three equal parts. So let's divide this line segment into three equal parts. 1, 2. Okay. So find the point of division nearest to P. So find the nearest division nearest to P. So in this case, if we have a point A and point B, so the nearest division in this figure is our P at the lower side. Nearest, meaning farthest man. Okay, so first, we need to determine the value of K. So let's find K first. K is equal to your A, P bar all over AB, which is equal to, so how many line segments from A to P? We have 1. And from your A going to B, 1, 2, 3. Okay, so RK is 1/3. So let's recall the formula in determining our values of X and Y. So for X, so let's solve for X. Solving for X. So X is equal to X sub 1 plus K X sub 2 minus X sub 1. And solving for Y, we have Y is equal to Y sub 1 plus K Y sub 2 minus Y sub 1. Okay, so let's recall our given data. So at point A, this is our X sub 1 and Y sub 1. This is our X sub 2 and Y sub 2. And the value for our K is 1/3. Okay, so let's substitute the value to determine the value of X. So for your X sub 1, we have 2 plus our K 1/3 plus our quantity X sub 2, which is 8, minus our X sub 1, 2. So finally, our X is equal to 4. And solving for your Y, okay, for your Y sub 1 is negative 6 plus 1/3 quantity Y sub 2 is 3 minus negative 6. Okay, so your Y is equal to negative 3. Therefore, your point P, x and y is located at 4 and -3. So 4 at -3. So let's locate 4 is 4 and -3. So that is the actual location of your P, nearest to point P. So A, nearest to point A. Okay. So let's have another example. So example number 2, the line segment from A to B is extended twice its own length, and we need to find the terminal point A. When we say terminal point, ibig sabihin end point, katapusan, dulo, terminal point. So first is we need to plot the given points in a Cartesian plane. So with y-axis, x-axis. So our first point is -2 and 2. So -2, 1, 2, and -2. So we have point A, -2 and -2. And for our second point, it is B. B, 1, 2, 3, and 2, 1, 2. So these are point B, 3 and 2. So other data from our problem is extended twice its own length. So if A to B is connected, then your terminal point is located twice its own length at the end of this line segment. So let's assume this is our extended line segment. So at a certain point, at its terminal, may kita point X and Y. So that's your terminal point, which is mao natin gidetermine. Okay? So first is we need to determine the value of K. So let's find K. Okay? Is equal to our first point muna. So going to P 1 and P sub 1 and P sub 2. So point 1, so or A to P, AB. Okay, so A to P, we only have what? Since it is twice its own length, so twice, we have 3 segment, 1, 2, 3. So 3 segment. And for your A to B, we only have 1. Therefore, a value of our K is 3. Recall the formula for our X. In finding X, so X is equal to X sub 1 plus K X sub 2 minus X sub 1. And for your Y, we have Y sub 1 plus K Y sub 2 minus Y sub 1. So let's substitute the value. So for our given point, this is our X sub 1 and Y sub 1. And our second point, this is your Y sub 2 and y sub 2. This x sub 2 and y sub 2. So let's substitute the values. So x sub 1 is negative 2 plus uk 3. X sub 2 is 3 minus negative 2. Finally, your x is equal to 13. And for your y, substituting the value, y sub 1 is negative 2 plus 3, your k, and y sub 2 is 3. Sorry, this is 2. So y sub 2 is 2 minus negative 2. So your y is equal to 10. Okay. So therefore, your terminal point x and y is located at 13 and 10. Okay, I hope it's clear for our line segment, division of our line segment. So let's have a last example. Okay, sample number 3. Find the midpoint of a line segment joining point A and B. So midpoint naman we're trying to locate the midpoint. So still our first procedure in solving this kind of problem, we need to plot the given points. So if we have given points, A is negative 2, 1, 2. And for your y, 1. So these are A, negative 2, and 1. So for your point B, 4. 4. And for your y, 5. 5. So these are point B, 4 and 5. So let's connect the line segment. Okay. Problem is find the midpoint of the line segment joining the two lines. So our midpoint. So let's assume our midpoint, midpoint xm and ym. So let's recall our formula. So xm is equal to x sub 1 plus 1 half, since it's in the middle, times your x sub 2 minus x sub 1. And for your ym, y sub 1 plus 1 half y sub 2 minus y sub 1. So in our given data, this is our x sub 1 and y sub 1. These are x sub 2 and y sub 2. So let's just substitute the given values to our formula. So x sub 1 negative 2 negative 2 plus 1 half x sub 2, which is 4, minus x sub 1, negative 2. So this is equal to 1. And for your y, y sub 1 plus 1 half, y sub 2, this is 5, minus y sub 1, 1. So this is equal to 3. So finally, our PM is located at 1 and 3. So I hope it's clear, our division of line segment. So please do your exercise number 3 and submit your answer and solution in your Moodle account on the approved time frame of your exercise 3. So thank you again everyone and have a nice day.